Continuing on with our chapter exploring all things repetition, we've considered while loops or condition-controlled loops, and these are loops that execute so long as the condition remains true. Another common pattern for loops are what are called counter-controlled loops. So these are loops that are based on the value of some counter variable. So we've seen a number of examples of these. So we start off with some counter variable initialized to a default value. The condition then checks is that counter variable at some upper bound. Then the body of that loop repeats once for each value of the variable, incrementing the counter with each iteration. Now we've seen a number of while loops that do this, so here's an example of one. So the counter starts at 0, and while counter is less than 10, we'll do something, and then we'll increment the counter by 1. This is called a counter-controlled loop because the number of repetitions is controlled by the values of that counter. This pattern is so common that it has its own kind of syntax. This is what's known as the for loop. The syntax for a for loop is slightly more condensed compared to an equivalent while loop, but both kinds of loops can effect a counter-controlled repetition. The for loop just happens to be a more natural way to express it. So the syntax of a for loop starts with the keyword for, and then we have some loop variable. This is going to be our counter, so it's just the name of a variable, commonly called I. Then we have another keyword here, in, which is a loaded word in Python, but for now we'll just know it as the keyword inside a for loop. And then we have some range. So the range function creates a range of numbers. It takes two integers as its input. These represent the start and end values for the range. So in this case, I say range 0 to 10 creates the values from 0 up to, but not including the last value 10. So in this case, it'd be 0 through 9. Now these values, 0 through 9, are each individually assigned to our loop variable, or our counter. So the counter will become the first value 0, and then we'll execute the body of the loop. Then the counter will become the next value, 1, and then we'll again execute the body of the loop. Notice this range tells us all the possible values for our variable, so it tells us the exact number of repetitions we'll expect this loop to execute. Now inside the loop, we have a loop body, which is a block of instructions that get repeated, just like in all of our while loops. And for each one of the values of the counter variable, we'll execute the loop body one time. And just like in a while loop, the colon and indentation are still important to denote where the loop body starts and ends. So let's look at an example. So on the left, a very simple for loop, and on the right, we have a variable table. So it says for I in range 0 to 3, print I, a very simple loop. So the first time our interpreter encounters this loop, the very first line says, create a variable called I and give it the first value in this range, which is 0. And then we enter the body of the loop, which says print the value of I, which is also 0. Then it goes back to the top of our loop and says get the next value from our range, which is 1, and then print that value. And then get the next value from our range, which is 2, and then print that value. And notice that's the end of our loop, because the range goes 0, 1, and 2, exclusive of its end value. So let's try this code out. I'll make a new file here. We'll call it fordemo.py. So using the same example we just had, so for I in range 0, 3, print I. Save our code. We could try it out. So Python fordemo, and that just prints out the values 0, 1, and 2 as we expected. But now let's modify it. Let's see what happens if we change some things. So if I change the range to being from 1 to 10, what do you expect the output will be when I run my code now? Make sure you understand it, and then let's try it together. So in this case, we have the range from 1 to 10, remembering that the initial value, the 1 here, is inclusive, and the final value, the 10, is exclusive. We end up with the values 1 through 9. If we change this code so we have a larger start than our end, and we run our code again, notice nothing happens because this range would be empty. So a question often arises, since while and for loops can both accomplish this counter-controlled loop syntax, when should I use a while loop and when should I use a for loop? The answer is you should use a for loop when you or your program know exactly how many iterations you expect your loop to repeat. If you know you want to print 10 letters or take 30 samples, so anytime a counter can control the loop, this is when you would use a for loop. You would use a while loop when it's unclear how many iterations you need. So this is, for example, when reacting to random numbers or reacting to user input. When some other condition should control the loop, then use a while loop. Next up, we have another challenge. Write a program that calculates and prints the sum of all numbers in the range 1 to 100. I should note that the for loop examples are all a bit dry because we always know exactly how many iterations we're going to run. So let's try this out. We have the sum of all numbers in the range 1 to 100. In VS Code, we'll make a new file. We'll call this one forsum.py. And this one is a challenge. Print the sum of all numbers in the range 1 to 100. Square brackets means inclusive. So I recommend pausing the video, making sure you can... I recommend pausing the video and trying this out, see if you can solve this challenge on your own. Then unpause and we'll solve it together. So if we want to print the sum of all numbers from 1 to 100, we're going to have to repeat through all the different numbers from 1 to 100, 1, 2, 3, 4, all the way up to 100, and add them all into a variable. So let's start by creating a variable that will hold this result. We'll call it sum equals 0. Next, we know we need to do some sort of repetition, so either a while loop or a for loop. In this case, we know exactly how many times we have to repeat. We have to repeat from 1 all the way to 100, so 100 total steps. So in this case, we can use a counter-controlled loop or a for loop. So I'll say for I in range from 1 to 100, sum plus equals I. So take all the values in the range 1 to 100, add them to sum, and then when we're done, so outside that loop, we'll print the sum. Save our work and try it out. Say python for sum.py. We got 4950. Now I happen to know that's not the correct answer, but if you haven't summed the numbers from 1 to 100 recently, you might not. So a way to test this is to use a smaller range to make sure the steps are working, and then we can generalize to the larger range at the end. So let's use a range that we can sum in our heads. So I know 1 plus 2 plus 3 is 6. Plus 4 is 10, so let's use the values from 1 to 4. Save our code and run it again, and here we got 6. Having just listed out the sums before then, 1 plus 2 plus 3 equals 6, so it seems like we're not including all the values. A quick reflection on our notes reminds us that the range here has an inclusive start and an exclusive end, so this 4 is not being included. So if we want to sum all the numbers from 1 to 4, we would say up to 4 plus 1, save our code, and run it again, and now we have our expected output. So if we want to sum all the numbers from 1 to 100, we're going to say 100 plus 1. Running our code again, we get 50/50, which I recognize as the correct answer. Another important thing to note is that we had to initialize our sum variable before entering the loop. Once our loops get more complicated, this might not seem as obvious, so let's see what happens if we initialize our variable inside the loop. I recommend, again, pausing the video and seeing what you think this will output, and then we'll run it together. So running our code with the sum equals 0 inside the loop, we end up with 100. Now this is an error I see a lot of times, usually when loops get bigger and harder to read. The initialization of your variable needs to happen before the repetition, because if we're initializing inside the loop, that means we're repeatedly initializing. So every step through this loop, we're saying sum equals 0 and then add a number to it. Then sum equals 0 again and then add a number to it. So as we can see, we've only got the value of the very last number because we had just initialized it to 0 and then we added 100. So all those previous steps, they all still happened, but the results got destroyed because we kept initializing inside the loop. Next up, let's say we wanted to extend this program to allow some user input. So rather than summing all the numbers from 1 to 100, let's ask the user for a number, we'll call it n, and then we'll sum all the numbers between 1 and n. So to accomplish this, we first get an input from the user. So I'll say input, enter a number. Any old number at all. Now we'll assume the user plays nice here and they do enter a number, so whatever they give us, we're going to convert it into an integer. Again, if they give us something that can't be converted into an integer, our program will crash, so we'll assume the user's playing nice for now. We will eventually learn how to drop this assumption, but for now, let's just assume the user plays nicely. Now the user has entered a number, we want to store that in a variable, so I'll say n equals that input. So now the user has entered, let's say, the value 100 or the value 1000, so n has the value of whatever the user entered. Next up, we want to make it so that our sum repeats from 1 all the way up to that user's number. So the upper bound in our range is here, so I would say n here. Now n is an integer, so it can be passed into range, but remember we want to sum all of the values, including the value the user enters. If they enter 100, we want to sum all the values, including the value 100. So we don't say a range from 1 to n, we say a range from 1 to n plus 1. Save our code, run it, and now it's asking us for a number. Let's test a number that we know. So 100 gives us 50/50, that's good. We could say 4, we've already tested, that's 10. And now we can try some really big number. So that number is maybe a bit too big. Let's try another number. Far fewer digits. And our code runs through and sums it up. So assuming we trust it to sum all these other values from 1 to 100 and from 1 to 4, we can expect this is the correct answer from 1 to 456,987. As a side note, for all the for loops I've used so far, I've used the variable I as my counter variable. You're free to use whatever variable names you like, although it's a good idea to use meaningful names. Here I've followed common convention and used the variable letter I to represent the iteration or counter variable, and the size of our problem represented by n. Next, let's see if we can modify this program a little bit. I'm just going to make a copy of it. Call this for some even. All the numbers in the range from 1 to n. Instead of being all the numbers, we'll say all even numbers in the range from 1 to n. So we have our user entering their value n. We're going to sum up all the values, but now we don't want to sum every single value. We want to sum just the even ones. Again, I encourage you to pause the video and see if you can solve this on your own. But now let's solve it together. So we saw a number of solutions to solving a similar problem. One possible solution is to say, take our range from 0 to n divided by 2, and every time we're adding in I, we can add in I times 2 with each step. So when it's 0, we're adding 0. When it's 1, we're adding 2. When it's 2, we're adding 4. Another possible solution is to use our if statement as we saw before. So we'll just go through all the numbers and say, if I mod 2, so if our current number is evenly divisible, I mod 2 equals 0, has no remainder, then we'll do our sum. Sum plus equals I. So this gives us all of the even numbers in the range from 1 to n. Run our code again, goes for some even. Enter a number, we'll say 10, and we get 30. Perhaps a number that we can do quickly in our head. I'll say the number 5. So that's 0 plus 2 plus 4, and we get 6. The reason I bring this up is because there's many ways to solve this, just as before. We can do a range of 0 to n over half, or we can even do steps of 2. To accomplish a different stepping, we'll have to learn a bit more about the range function. So the range function generates numbers in the range given. So if we give it a start and an end, it will start at the start value and it will end exclusive of the end value. We can also just include a single value, and that will generate numbers in the range 0 up to but not including our end value. As a third way, we can include 3 arguments, and these are the start, the end, and the third one is considered the step size, or the size of our increment. This generates numbers in the range start to end as before, but skipping by increments of step. Returning to our example, instead of using the if statement to filter out all the values that we don't want, we can change our range to go by a step of 2. Notice, however, a range starts at 1, so if we're going up by steps of 2, that's going to be all of the odd numbers, 1, then 3, then 5, etc. So let's start at either 0 or 2, so that we have the even numbers only. Save and run our code, and we can try out all the values from 1 to 5, so that should be 2 and 4, which is 6. And if we go up to, let's say, 10, that should add in 6, 8, and 10 for a grand total of 30. So that's the range function. Now, to make sure that everyone's on the same page, let's do a comprehension problem. So here is a daunting piece of code that, again, syntactically valid, but semantically is designed to be confusing. The purpose of this, again, is that you understand the code itself and not just the idea the code is describing. So while this may seem daunting, we'll just go step by step, just as the computer does. We'll start by creating a variable table. So in our variable table, we have the variables x, we have a y, and then we have an I. So x starts with the value 1, y starts with an empty string, and I starts with the first value in our range. So it's a good idea to write out the range as well. That way we can refer back to it easily. So the range in this code has the argument 5, which as we've seen means it goes from the values 0 up to but not including 5. So the values of this range will be 0, 1, 2, 3, and 4. Now our for loop says take the first value from that range and put it in the variable I. So I starts at 0. Now we have some if conditions. They won't really fit on the page here, so we'll track them in our mind while tracking the variables on paper. So the first condition says, if I is greater than 3, is that true? 0 greater than 3 is false. So false and anything is going to be false, so this whole condition is false, and we skip down to the next one. That says if y is empty, which it is, so that's true, or, and then all this other stuff. True or anything is going to be true, so we enter this branch of our loop. So this says x plus equals I. So take the value of x, take the value of I, sum them together, and store the result back in x. In this case, still 1. Next it says y gets the string of x. So the string of x is just the string 1, so y gets the value 1. Now if, elif, and else are all connected, so we're only going to do one of those branches. Since we did the elif branch, that means we're done with all of those. There's nothing else inside this for loop, so we go back up to the top and we do the next iteration. That means I takes the next value from the range, so now we're at 1. So I gets the value 1, and we enter our loop again. Is 1 greater than 3? That's false, so this whole expression is false. Is y the empty string? That's false, but an or could still be true, so we'll check this next part of the condition. X plus I, so 2, is greater than or equal to x times I. So x times I is 1. So is 2 greater than or equal to 1? That is true. So we enter this again. X plus equals I. So we take these two values, x and I, sum them together and store them back in x. And we concatenate the next value of x onto y. So plus equals, when we're dealing with strings, isn't addition. It means concatenation equals. So it's the same thing as if we had said y equals y plus the string of x. It says take the value of y, add on the string of x, and store the result back in y. So in this case, we get 1, 2. Again, the elif occurred, so we skip back to the top of our loop, and I takes the next value. So I is now 2. Might need a bit more space. If I is 2 greater than 3, that's still false. Come down to the next branch. Does y equal the empty string? That's false. X plus I, so 2 plus 2 is 4. Is 4 greater than or equal to 2 times 2, which is also 4. So 4 is equal to 4, so that's true. And we enter this branch again. X plus equals I, so 2 plus 2 is 4, and store that back in I. And take the value of x and put it into y. So we have 1, 2, 4. Back to the top of our loop, we get the next value, and now it's 3. Is 3 greater than 3? That's still false. Is y the empty string? That's false. X plus I is now 7, and x times I is 12. 12 is bigger than 7, so this is false. So this whole statement becomes false, and we fall down to the else branch. The else branch, we don't have to check anything, but it says x gets incremented by 2, so x now equals 6, and y gets a dot. So y becomes 1, 2, 4, dot. It's the end of that iteration of our loop. We go back up. I takes the next value from the range, noting this is the last value from the range. And we start again. So if 4 is greater than 3, that's finally true. And if x, which is 6, is less than 8, which is also true, so true and true is true, we enter this branch of our if statement, and y gets the value of the string of I plus x. So I plus x is 6 plus 4, so 10. Turn that into a string, we have the string 10, and then we concatenate that to the end of y. So x didn't change, but y becomes 1, 2, 4, dot 10. That's the end of that branch. And again, all of the if statements are connected, so we don't do any of the other branches. Go back to the top of our loop, our range is empty, so now the loop is done. We exit the loop, and we finish off our code with print y. So our output, if we had an output section, just prints out the value of y, which is 1, 2, 4, dot 10. I encourage you to copy this code into your IDE, give it a run, and make sure that this all works out the way you expected it to. Okay, let's do one more comprehension. This one's a bit shorter, thankfully. What is the output of this code? So let's go back to our variable table here. So we have a for loop that creates a variable called I, and a range 20, 0 by -1. So that's starting at 20, ending at 0, exclusive, and going down by 1, so decrementing by 1 with each iteration. So that's 20, 19, 18, 17, all the way down. So our range is going to be 20, 19, 18, put dot, 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 so I don't have to write them all, 3, 2, and then 1. Notice it doesn't include 0. The end value is still exclusive. And I takes the first value from that range, so 20. And now let's go through our loop. So if I mod 2 equals 0, so if we divide I by 2 and there's 0 remainder, so 20 divided by 2 is 10 with 0 remainder, so that's true. Another way of saying that is I an even number, which is true? Then we'll multiply I by 2. So I becomes I times 2, 20 times 2, which is 40. Then we'll print the value of I, so let's put our output section here. Our output has the current value of I, which is 40. That's the end of our loop. We go back up to the top, and I takes the next value from the range. Notice, even though we've changed the value of I, the range is still consistent. So we've already used the 20, now we go on to 19. So the next value of I is still just the next value in that range. Every iteration, the variable takes a value from the range, and other changes to that variable are erased. So I takes the next value from the range, which is 19, and we enter the loop again. We say if I mod 2 equals 0, so now 19 divided by 2 is 9.5, or 9 with one remainder. So this is not equal to 0. 19 is not an even number, so we skip that if statement and we print the value of I. Then we go back up to the top, and I takes the next value from the loop, 18. And now it says if I mod 2 equals 0, 18 is an even number, so that happens. We multiply it by 2. 18 times 2 is 36. And then we print out the value of I, so it prints out 36. Then the loop is done, and it takes the next value from the range. So we just took 18, the next one would be 17. Following on from this pattern, we can more or less start to assert what the outcome will be. It takes on the 17. Anytime there's an even number, we print twice that even number. So that would be 32, and then 15, and then 28, and then 13, 26, etc. I'll leave this as a homework exercise to walk through all of the remaining values, but hopefully the understanding is clear. The important thing to note here is the counter variable is reset every iteration. It takes a new value from that range. Next up, let's try a demo that isn't just strictly numbers, although all things in programming are ultimately numbers. This one has a bit of a drawing component. So I'm going to make a new file here called 4turtle.py, and I'm going to import turtle. Recall this is the turtle graphics library. It works sort of like an Etch-a-Sketch. It's just a pen on a paper that you tell it to move forward, turn left, turn right, etc. Now I'm going to use the idea of repetition to draw a circle using turtle graphics. Note that there is a turtle.circle function that can just draw a circle on its own, but let's try it without. So the idea behind a circle is that the idea behind drawing a circle is that our pen needs to start at a point and go all the way around and return back at the same point. Now, if we do this with 90-degree turns, we end up with a square. If we widen the angle on those turns, but still go full circuit back to our original point, we end up with pentagons, hexagons, octagons, etc. So to draw a circle, we start our pen in the middle of the page. We need to move forward a bit and turn to the left slightly, and continue doing that until we return back to where we started. Now, if we turn by 1 degree to the left each time, then we need to do 360 of such turns in order to return back to where we came from. So we could say, for some variable in range from 0 to 360, turtle.left by 1, and turtle.forward by, let's say, 2. Exit on click so that we can see the result. And let's see this code. And as the code runs, we can see it moving and drawing a circle, very slowly and eventually reaching back to the place where it started. So there's a few things to note in this piece of code. First off, the thing that you might have noticed is I use the underscore as a variable name here. This is still a valid name. Recall that you're allowed to use underscores in your variable names. The reason I used it as the entire variable name, though, is because it indicates that it's an unimportant variable. We're never actually using the value of this range. We just needed a loop that repeated 360 times so they could move forward and turn left a little. So the actual values in that variable are unimportant. So the underscore here says it's unnecessary. It indicates to other readers of our code that this variable doesn't have value, but the loop does need to repeat that many times. Notice also I use the range from 0 to 360. While this doesn't include the last value 360, it does include the 0, so there's 360 total steps in this loop, which means turning left by 1 degree each time, we'll have turned left 360 times by the end of this loop. If we want to change the size of our circle, we can change these values around a bit. So instead of turning left by 1 degree 360 times, we could turn left, for example, by 36 degrees 10 times. That would still result in 360. So I'll say 36 degrees 10 times. Now let's change the size of our segments as well. We'll go forwards by, let's say, 10 pixels each time. So we rerun our code, and it opened up on the side window here. And we got a circle that's much smaller. So fewer turns made it back to the same place. If we'd like to generalize this code a bit more, we could use some variables here. So I could say num steps equals 100, and side length equals 10. Uppercase. And then we can use these values inside our loop. So I could say from 0 to num steps, that's the number of segments in our circle. We'll move forward by side length with each step. And now the number of degrees we need to turn is going to be 360 divided by the number of steps we're taking. So just 360 divided by num steps. So if we have 100 steps, that's 3.6 each time. If we have 10 steps, then that's 36 each time, as we've seen. So let's save our code, try it again. And we have a circle similar to how we saw it before. If we want, we can augment that and make it even a little bit bigger. Run our code again. And we get this circle that's much bigger than the screen, but if we wait for it, it eventually comes back to a full circle. So it's just another example of loops. Again, notice we know exactly how many steps we need to take, so we're using a counter-controlled loop so that we can repeat exactly that many times.